Phil has 20 sweets in a bag. 5 of them are orange, 7 of them are red, 8 of them are yellow. He takes 2 sweets at random from the bag. We need to work out the probability that they will not be the same colour. So I'm just going to draw a tree diagram. It's not strictly necessary, but it will help me to explain this and organise my thinking. So the first sweet that's taken could be orange, red or yellow. The probability that the first sweet is orange is 5 out of 20 because there are 5 orange sweets and 20 sweets in total. So you've got 5 chances out of 20 to get an orange. Red would be 7 out of 20. Yellow would be 8 out of 20. So that's the first, there's the probability of the first sweet being taken of different colours. He takes a second sweet. So if the first sweet he took was orange, then again he could take an orange the second time, he could take a red the second time, or he could take a yellow the second time. Now we're assuming that he's not going to put that first sweet back. We're assuming that there's only going to be 4 orange sweets left. He's taken one of the orange sweets out, so there's only going to be 4 left. And there's only going to be 19 sweets left in the bag. So the new probability of the sweet being orange is 4 out of 19. We're making that assumption that he didn't put it back because it doesn't say that he did. And it'd be a bit weird if he did, really. So we're assuming that he's not putting that sweet back. So the probability of it being orange is 4 out of 19, given that he took an orange one out. The probability of it being red would be 7 out of 19, because there's still those 7 red sweets left. He only took an orange one out. He didn't touch any of the reds, so there's still 7 red ones left. And similarly, there is still 8 out of 19 yellow sweets. And it's always worth doing a quick check. Do these numbers here, do they add up to 1? If you did 4 plus 7 plus 8, that adds up to 19. So 19 out of 19 is 1. So we know we've got that correct. That's if he took an orange out the first time. If he took a red out the first time, so again, he could get an orange, a red or a yellow the second time. Now this time, it's the red counters, the red sweet that's gone down. So there were 7 red sweets. There's now only 6 left because he took one of them out. There's still 5 orange sweets because there were 5 in the first place and he only took a red one out. So the orange stays the same. And similarly, the yellow stays the same. That's still going to be 8 out of 19. And again, it's always worth doing a quick check, add them up to see if it adds up to 1. And the final case is if he took a yellow out the first time. Again, orange, red, yellow. The yellow is what goes down now. So he took a yellow out, so that's 7 out of 19. The orange stays the same, so that's 5 out of 19. The red stays the same, so that's 7 out of 19. And again, check to make sure that adds up to 19 out of 19. Right. Okay, we've got 2 options of what we do with this now. We want to work out the probability that the sweets will not be the same. So that could be orange and red, orange and yellow, red and orange, red and yellow, yellow and orange, yellow and red. So you could work out what all of those are going to be by doing 5 over 20 times 7 over 19 for the orange and red. Then doing 5 out of 20 times 8 out of 19 for the yellow, orange and yellow, and so on, and then add all of them together. That would give you the probability, the total probability that the sweets are not the same colour. But that's quite long. Instead, what I'm going to do is I will work out the probability of orange and orange, red and red, and yellow. So I'm going to actually work out the probability the sweets will be the same colour, and then I'll take that away from 1 to get the probability they will not be the same colour. So the probability they will be orange and orange, that's going to be 5 out of 20 times 4 out of 19. The probability of the first sweet being orange multiplied by the probability that the second sweet is going to be orange. And that will make 20 out of 380. The probability of the first sweet being red is 7 out of 20, and the second sweet being red is 6 out of 19. Timesing those together for them both to be red is 42 out of 380. And then finally yellow and yellow, so that's 8 out of 20 times 7 out of 19, which is 56 out of 380. So if we take those away from 1 now, that will give us the probability that they will not be the same colour. So let's do that. Taking the probability that they are the same colour away from the probability away from 1 will give us the probability they're not the same colour. And there we go. We get 131 out of 190. That's the probability that they will not be the same colour. So all of these other ones here would all add up to 131 out of 90.